Okay, so we've seen that the equation we see here, simple first order linear non-homogeneous equation with obvious solutions. Okay, you're going to have an e to the minus 4t, some coefficient of e to the minus 4t, and it could be any coefficient, and then plus a linear combination of sines and cosines of 5t. And that's going to come out of this form here. Okay, so we've substituted into the, or we've transformed the equation, and we've solved for L of y, so that y is the inverse transform of this expression, and this expression can be written in terms of partial fractions. Thus, so here's where we are. Y is the inverse transform of this, where this is equal to what we got when we solved the transformed equation for its Laplace transform. Well, this is then going to be the inverse transform of A over S plus 4. The inverse transform is linear. Inverse transform of this plus this is the inverse transform of this plus the inverse transform of this. Also, kind of skipping a step here, but this is just bs over s squared plus 25 plus c over s squared plus 25. So again, using linearity and skipping the step where we break this down into two terms. We get L inverse of bs over s squared plus 25 plus L inverse of c over s squared plus 25. Well, that's just equal to A times the inverse transform of 1 over s plus 4 plus B times the inverse transform of s over s squared plus 25. Looks like I can't even write it too coherently, but it's a little simple motor problem there. Hand got ahead of the brain. S squared plus 25 plus C times the inverse transform of 1 over S squared plus 25. Well, I can write this one down easily. That's A times e to the negative 4t, whatever A turns out to be. This is, now this is a little more complicated, because remember that I had a good place to write it down, I would. But remember that the Laplace transform of sine of kx or kt is k over s squared plus k squared. So that, what would you transform to get 1 over s squared plus k squared? Well, you would transform 1 over k times this. In other words, 1 over s squared plus k squared is the Laplace transform of 1 over k times the sine of kt. Similarly, transform here. Inverse transform of s over s squared plus k squared. The inverse transform of, well, let's do it. Let's write it out. So I'm going to have to write a few notes down here. We don't want to make you think that hard. Okay, so the Laplace transform of the inverse transform of k over s squared plus k squared is the sine of kt. So the inverse transform of Laplace transform of s okay, using up board space I don't really want to. Plus transform of the sine of kt is s over s squared plus k squared. So the inverse transform of s over s squared plus k squared is the sine of kt. And let's look back again. So again, we see this, and we also see mixing up the sine and cosine. Again, with apologies. Okay, let's get this right. I mean, I said it right a minute ago, just not keeping my mind clear enough to write it down correctly. Okay. Okay, so let's see if we've got it right. There we have it. And if it's a cosine, the s goes there. For reasons, again, that are clear if you remember the steps of the derivation. Okay, so the inverse transform of k over s squared plus k squared is the sine of kt. So the inverse transform of and I'm wanting to do this. Okay, this is over here. Okay, well this is going to apply over here. Inverse transform of 1 over s squared plus k squared would then be 1 over k times the sine of kt. So, inverse transform of 1 over s squared plus 25 is 1/5 the sine of 5t. And that's going to give us the term here. It's going to be c times 1/5 times the sine of 5t. Over here, the inverse transform of s over s squared plus 25, well, that is just the transform of the cosine of 5t. And you can look at the table, you can think it through. But the cosine of 5t has Laplace transform s over s squared plus 5 squared. So basically, you've got to worry about k when you do the inverse transform of just 1 over s squared plus k squared. We have the cosine. You don't have the k up here, and you don't have to worry about dividing by that constant. Okay, well, there it is. There's our solution. If we can solve the simultaneous equations for our partial fractions. So we better go ahead and do that. And we will as soon as I arrange enough board space. Okay, so, well, stop the video for a minute.